This briefing video will cover the Friedel acylation reaction. So here at the top of the slide we've got the reaction scheme, and the Friedel is a variation of electrophilic aromatic substitution. So the aromatic component here is going to be toluene, which you're also going to use as a solvent for the reaction, and that's going to react with this sort of cyclic anhydride. Now, in terms of the theory of the reaction, in terms of how this works, this was covered in first year organic lectures. So if you want to refresh your memory of the mechanism and other associated theory, such as, for example, why it adds opposite, so para, to the methyl group of the aromatic ring, then you should review your lecture material or organic textbook. The purpose of this experiment is to give you practice at performing a number of skills, and in particular some of the key skills I want to highlight is doing a reaction under controlled conditions, so setting it up so you've got like a multi-neck flask, and also a distillation as well. Although this variation of a distillation I'll explain a bit later, the purpose of that distillation is actually to remove the toluene that you've finished with at the end of the reaction. So to refresh your memory of how to perform some of these techniques, do make sure you watch the Prelab videos showing you how to perform these techniques correctly. In terms of the structure and planning of this experiment, it's timetabled for you to run in your sort of second block of lab experiments. Okay, so one of the things you'll be doing is finishing off one of the steps from your other experiments. So we kind of left a gap for you to do that on your first day. And then if you do that, you should finish your other experiment in the morning and be able to start the experiment, this experiment, in the afternoon. So you could do sort of the starting of the reaction, so heating things up together, doing the steam distillation to remove the toluene, okay, giving you a crude product, and then the following day you can do your hot filtration and recrystallization in the morning, and then just finish off with the analysis in the afternoon. Okay, so what we've got is your heating and stirring the reaction together under controlled conditions, and then you're going to use set things up for a steam distillation. Okay, so as I mentioned, it's to remove toluene, but toluene has a high boiling point above 100 degrees, and so it's hard to remove, certainly to heat it up without decomposing your product. So one of the things you can do instead is you can add water and distill the toluene off with water, and that's because toluene and water can azeotrope off together. So that's what you're doing in this distillation. And so one of the key things to remember is, because you're removing toluene in this distillation, you don't want to keep the distillate. You want to keep the original flask that you're heating. This is where your product is going to reside. And then you're going to do a hot filtration to remove insoluble impurities, and then a further recrystallization as well to get a nice solid out at the end. Okay, so do look through the Koch forms of the experiments to make sure you are familiar with how to handle the chemicals safely. Part of the questions are the pre-labs, to ensure that you can do this for this experiment. And also to remember is that, if you do forget, these hazards are going to be in your lab scripts as well. So just before you're about to handle a chemical, if you've forgotten or unsure what the hazards are and how to handle it safely, just check in your lab script in the Koch form before using it. Okay, so here are some tips then for doing the reaction successfully. So aluminium chloride, it can react with water, and so if it reacts with water, it can't act as a catalyst for this reaction, and therefore that's going to decrease your yields. So when it comes to setting up this reaction, it's really important that the glassware in your setup is nice and dry. If you're what you can do is you can sort of dry things in the oven or use a heat gun if you wish, but you can't have any water present. And then this is a diagram showing you what the apparatus of the steam distillation is. So you can have your reaction mixture in here containing your product and toluene. This separating funnel is so you can drip in and add water to azeotrope off the toluene. You'll be heating the reaction, there'll be a hot plate and dry sim block underneath. Then as you're heating up, okay, it should come over and the toluene should collect. You can have a round bottom flask, you could have something else like a conical flask. It doesn't matter for this distillation, but remember your product is going to be in the flask that you're heating. Okay, so that concludes the briefing video for the Friedel Crafts experiment.